Bismillahirrahmanirrahim. Assalamualaikum. My name is Siti Nursyuhada Baharudin from University Technology Mara, Campus Arab. So today I will presenting my final year project, research review entitled An Overview on the Recycling and Modification Methods of Engineering Thermoplastic that supervised by Professor Madya Dr. Razi Muhammad Nordin. So here is the outline of research review. In introduction, I will cover 4 subtopics: background of study, problem statement, significance of study, and objective of study. Background of study. So what is the thermoplastic and engineering thermoplastic? So thermoplastic is a plastic that can change shape due to heating and can reshape to its normal shape. It is a non-biodegradable material and can be obtained in 2 types, which are crystalline thermoplastic and amorphous thermoplastic. Both have different thermal, physical, and electrical properties. This thermoplastic commonly used as container, water bottle, and grocery bag. Engineering thermoplastic is a resin with an excellent mechanical, chemical, thermal, and electrical properties. Also can be obtained in 2 types, which are crystalline engineering thermoplastic and amorphous engineering thermoplastic. In this review, it will focus on polycarbonate, polyamide, and polyester. This engineering thermoplastic commonly used in construction, medical, and transportation application. Every year, about 40 million tons of plastic are produced. About 50% of plastic is used as single-use application, while about 20 to 25% of plastic is used as a long-term application, and small percent also used in durable consumer application. As the plastic production increase, the waste of plastic also increase. That can cause harmful to environment. So the suitable treatments are important. Next is significance of study. Engineering thermoplastic is a synthetic plastic with high performance that resists to mechanical stress, resistant to corrosive, and temperature extreme resistant. The thermoplastic resists to degradation due to non-biodegradable material. So recycling and modification method is applied to control the production of plastic waste. So the objective of this research review first is to review the recycling method in engineering thermoplastic. The second one is to review the modifications of engineering thermoplastic. Let's move into part 2, the recycling and modification methods for polycarbonate, polyamide, and polyester. Recycling method. So recycling is a converting process of waste material into new material. Plastic recycling can reduce carbon dioxide emission, usage of petrochemical feedstock, and maintain ecosystem. There are 2 types of recycling methods, which are mechanical and chemical recycling. Mechanical recycling is a process where the plastic waste is reused as new raw material. It is involving several steps, such as sorting, cutting, contaminant separation, processing, and milling. Chemical recycling is a chemical process that converts polymer into monomer and oligomer. It is involving the changes of chemical structure. The example of chemical recycling are hydrolysis, methanolysis, alcoholysis, and pyrolysis. Recycling of polycarbonate, or known as PC. It can be undergone by mechanical and chemical recycling. In mechanical recycling, the PC undergoes several steps, such as crushing, grinding, melting, and extraction. This method do not change the chemical composition and does not cause environmental pollution. It can extend the service life of PC as it is reuse cycle. However, the reproduced PC exhibit the deteriorative property such as lower the resistant impact. while in chemical recycling, the PC is converted into monomer and be reused as raw material to produce new PC. It can produce pure monomer and eco-friendly methods. The methods usually used are alcoholysis, pyrolysis, and hydrolysis. Recycling of polyamide, or known as PA, also can be obtained by mechanical and chemical recycling. In mechanical recycling, it is involving remelting and spinning process. The method lowers the value of product due to contamination and degradation. In chemical recycling, it is involving depolymerization into cyclic monomer. It is occur at elevated temperature and high pressure and catalyst. The reactivity of PA depends on depolymerization agent such as ammonia, water, and glycol. Recycling of polyester. Polyester only undergo chemical recycling such as hydrolysis, alcoholysis, enzymatic degradation, and reductive depolymerization. Mostly focus on recycling PET or polyethylene terephthalate. There are two types of PET recycling, hydrolysis and glycolysis. In hydrolysis, it is undergo under acidic, alkaline and neutral condition, while glycolysis it is involving cleavage of ester bond. Modifying techniques is a modification process to enhance the performance of polymer. There are three methods of modification: copolymer, blend and alloy, and additive. In copolymer, the polymer is derived from more than one species of monomer. The process is known as copolymerization. For blend and alloy, blend is a simple mixture of two mutually soluble compounds, while alloy is a non-soluble mixture of compounds. There are two types, single-phase and multiple-phase. In single-phase, the polymer is dissolving to each other or well mixed, while multiple-phase, it is involving two or more different polymers that uniformly interdisperse to each other. While additive is done by stabilizer, processing aids, aesthetic additive, and performance enhancing additive. Modification of polycarbonate. So one of application is blending PC with PVC or polyvinyl chloride. It is to overcome the folly problem of polymeric membrane in water and wastewater purification process. Folly is caused due to polymeric membrane property, which is hydrophobic. The PC will increase the hydrophilicity of membrane, while PVC is used due to its thermal and chemical stabilization properties. So the combination of PC and PVC will increase the anti-fouling property. Modification of polyamide. The application is blending PA with PPE. PA commonly used in electronic and automobile application. However, PA can cause drawbacks such as poor stability, poor to use, and high moisture absorption. PA-PPE blending can solve the drawbacks. The PPE is used due to excellent dimensional stability and good resistance to water and temperature. Next is modification of polyester. The application is polyester polymer alloy, or known as PEPA, is applied in dialysis membrane. PAPE is a synthetic polymer membrane. It is derived from two polymers, polyether sulfone (PES) and polyarylate (PAR). PAPE consists three layers: skin layer on inner surface, porous layer, and lastly skin layer on the outer surface. The pore size of membrane is controlled by PES and PAR ratio. The last part is conclusion and recommendation. So engineering thermoplastic is widely used as they have unique characteristics such as good mechanical, chemical, and thermal properties compared with commodity thermoplastic. As the engineering thermoplastic become a worldwide product, the manufacturing become extravagant that contributes some environmental pollution due to lack of waste management. The plastic waste must be degraded by proper way in order to maintain the clean environment. So the recycling process carried out are different for different types of engineering thermoplastic. For recommendation, it should be focused on molding technique such as ultrasonic molding and injection molding of engineering thermoplastic and the effects. Also consider about the mold geometry and, processing condition such as baking pressure, cooling time, and cooling ratio. So that's all for me. Thank you.